Alright, so today we're talking about modeling and density. So the first thing to go over is density. It is the amount of matter that an object has in a given unit of volume. Okay, the density formula, you might have already seen it, is density is equal to the mass divided by volume. Okay, so we're going to go ahead and just start finding the density problem. So the first thing I need to do, so you can see here my problem is a cylinder. It has a diameter of 6 centimeters, a height of 17 centimeters, and the mass is 254 kilograms. Okay, so my first step is going to be find any missing information. Okay, so the first thing I need to notice is that the diameter is equal to mass over volume. Well, I'm given my mass, right? So I need to now calculate the volume. So that is going to be what my step one is, to find the volume. Now, if we remember, the volume of a cylinder is equal to pi r squared times h, or pi times the radius squared times h, okay, which is the height. So I'm just going to go ahead and replace my values. Remember that my diameter here is 6, meaning that's from the entire length of the cylinder, right? But I need half of it, so I'm going to divide 6 by 2 to get 3. So 3 squared times my height of 17 centimeters times pi. Okay, so now 3 squared is going to be 9 times 17, right, times pi. So when I multiply 9 and 17, I get 153 pi. Okay, and I'm going to leave it with the pi at the end. Depending on, like I've told you before, depending on the question is when you need to determine if you are going to have to multiply by pi. Okay, so that's just the first part. So my second part is going to be to find the density, right? I've already found all the information I need. So now I just need to find the density. So remember that my density is mass over volume. Okay, so I'm going to put D is equal to my mass, which is 254 kilograms, over my volume, which is 153 pi, and it's actually centimeters cubed. Okay, and then when I go ahead and I solve that problem, remember I want to multiply by pi itself. So when I put it in my calculator, I'm just going to multiply using the pi key, not 3.14. So if I were to do that, it would be 254 divided by 153 times pi, and that will give me the density. So when you guys do it in your calculator, you can go ahead and solve it that way. But I'm going to leave it like this for now, okay? But that's generally how I find the density. I need to find the missing information and then just plug it in, okay? Now, you can also use density to calculate a bunch of other things, including population density. Okay, so population density, you're going to use the formula of the density is equal to the population divided by the area, okay? So if you're given an example and the question is actually a figure, right, if you're given a graph, there's a lot of problems like that in your book. It's a very common example, and most likely on any test you'll see that versus one like the example I have here where it gives me the information. But we will be able to review how to solve that specifically later on, okay? But it's pretty straightforward. Once again, my first step is to find any missing information. Luckily, in this case, I don't have any, right? I'm given my population, I'm given my area. So I can just jump straight in to finding the population density. I'm just going to call it the pop density. And that's going to be the population density is equal to the population, which is 109,000, over 160 kilometers squared. And this is people. Now, the most important thing to remember is that when you are talking about people, okay, you are always going to round usually to the nearest whole number, right? You can't have point half of a person. Okay, so when I do this division, I'm going to round to the nearest whole number, which is 681 persons per kilometer squared. So what that means is that for every square kilometer, okay, there's 680 people in that area. Okay, so that's how you would use population density. Okay, now one of the last things we're talking about is the British thermal unit, or the BTU. Okay, this is a unit of energy that is approximately the amount of energy needed to increase the temperature of 1 pound of water by 1 degree Fahrenheit. Okay, it may be measured in BTUs per unit of volume. So you would actually see it as BTU per volume. Okay. And now we're going to go ahead and figure out how to calculate it. So we have here in my example, a spherical tank is filled with a gas and it has dimensions shown. So you can see the circle there, the sphere at the bottom. Okay. Find the number of BTUs produced by 1 cubic feet of the gas. Round to the nearest BTU. So when it says round to the nearest BTU, what it's saying is round to the nearest whole number. Okay, so now it tells me when the tank is filled, it provides 116,151 BTUs. Okay, so my first step, remember I'm finding per cubic foot. So if I'm looking for cubic feet, well, that means I need to find the volume. So I have to find the volume of the sphere. Okay, so remember that it is volume is equal to 4/3 pi r, and this is the one that is cubed, so pi r cubed. Okay, and once again, I'm given my diameter is 6 feet, so my radius is going to be 3. So it's 4/3 times 3 cubed pi. Okay, now I know 3 cubed is going to be 27 pi. Okay, now when I do this, I'm going to multiply 4 by 27 and then divide by 3. When I do that, what I end up with is 36 pi. Okay, if you do it in your calculators, you'll get the same thing. 4 times 27 divided by 3 will give me 36. All right, so that's done. My second step is to set up a proportion. So this is where we kind of have to know our conversions, right? So when we set up a proportion, what ends up happening is I have every BTU is in 1 cubic feet. My question tells me that. 1 cubic feet per gas. Find the BTUs. The other thing is my definition specifically says BTUs per unit of volume. That's actually what I wrote over here. Okay, it's the same thing. Now, this is going to equal BTUs in the tank over the volume of the tank. Okay, so that means that I'm going to have 1,151 BTUs over 36 pi feet cubed. Okay, so when I divide this, right, remember I'm going to do that 116,151 divided by 36 times pi. Okay, when I do that, I'm going to cut a couple corners here, and I'm just going to let you know that it's going to round to the nearest whole number is 1,027 BTUs. Okay, so now since we already went over all of these, for your practice problems that I'm going to need you guys to complete, okay, and these will be due on, we'll make them Friday. So in your book, it's going to be page 1051. This is in the actual textbook, not in the online one. So on page 1051, you're going to do number 2, okay? And what you're going to do is you're going to find the density, and then you're going to tell me which one is denser, okay? So which one has the bigger density. Then on page 1052, you're going to solve number 4. And then the last one you're going to do is you're going to go to page 1053, and you're going to solve number 9. So those are the 3 problems you're going to need to solve, and those will be due on Friday.